Here in this video, we are going to discuss about improper fraction. Now, if you remember that in our previous discussions, we used this diagram of a pizza. We suppose that it's a pizza. Here it's one pizza, and we suppose that here we have four pizzas, similar pizza here, but we have four in the count. And then we discussed about fraction, the proper fraction, and even we discussed very briefly about improper fraction. But in this video, it is going to be specifically about improper fraction. Now I'm going to use the same diagram or example to tell you. First, I'll tell you about briefly about proper fraction, though we have a separate lecture on that, but it's important to tell you so that we can compare the proper fraction and the improper fraction, so that you can understand the difference, so that you can relate the two discussions. Okay, but as always, I'll again repeat, please go to the playlist and watch videos on fraction. We have two parts on the fraction, then we have a proper fraction. We have discussed fraction in a very detailed way, so that will be really helpful for you to understand this video. Anyway, let's just get started. So let's suppose that we have this pizza. We have this pizza, right? So I'm not going to discuss in a very detailed way about proper fraction, but still I'll try to just talk about proper fraction in a little detailed way. Okay, so let's say that this is our pizza. Let's say this is our pizza, and same pizza. Here we have this Control X, sorry, Control Z, we have Control C, and Control V. So this one, 2, then this is 3, and then this is 4. Okay, if this is 1, 2, 3, and 4, let's take one more, 5. So let's say that it's here. Let's put it here, and let's put it here. Okay, so we have this pizza. Just first focus on this one. This is our pizza. Okay, and if there is a person A, if there's a, let's say that there are four boys. Let's say that there are 4 boys. So 4 boys. Okay, so this is first boy, this is second boy, this is third boy, and this is fourth boy. Okay, now if this particular pizza, okay, we are going to consider this one pizza as a whole. We have discussed all these things in the previous videos. So we are going to take this pizza as a whole, as a single unit. Now we'll perform fraction on this, and whatever fraction we'll perform, that will be a proper fraction. So if I have to distribute this pizza into these 4 boys, then of course it will be like first I'll divide this and I'll divide this, right? So if this is a pizza and I have divided this pizza into 4 equal parts, then this will be the 1/4 part, because this is a single part out of 4 equal parts. This is another single part out of 4 equal parts. This is another single part out of 4 equal parts, and this is another single part out of 4 equal parts. So this is 1 by 4, 1 by 4, 1 by 4, 1 by 4. Now, of course, if let's suppose that here we don't have these four boys, but just a person A. Let's suppose that there is a person A. Now, if this person A gets only this part, this first part, so it will be said that this person A, if this person gets this part, he or she, doesn't matter, gets this part, so this will be 1 by 4 because this person is having one part of this pizza. If this person gets this part also and this part also, in that case you will say that since he has got two parts out of these four parts, therefore this is 2 by 4. And if that person gets three parts, that is this part, and this part. Now since he has three parts, therefore he will have 3 by 4 portion of the pizza. If that person is having this part also, you will say that, hey, since he got this one, this one, this one, this one, now he has 4 parts, and in fact he has whole pizza now. So 4 parts out of 4 equal parts. So it's basically, it will be 1, 4 divided by 4 will be 1. It means now this person has got one complete pizza. Now if you can clearly see that by the definition of fraction, we discussed that fraction is actually a part, a broken part, or you have some sliced from a whole or object. So in this case, this is our object, and we are taking a part of this pizza, either 1 part or 2 part or then 3 part. So all these are parts of pizza, and that is why, since it is being taken from a single part, a single object, okay, therefore the fraction will always be less than 1. Imagine that you are having an apple and you sliced 1/4 of that apple and you took it off, right? Then again you sliced off another 1/4 and took it off, and then another 1/4, then you took it off, and another 1/4 you took it off. So whatever fraction that you're taking off is of course will be less than 1. Why less than 1? Because the object is only 1. So if you take out the fraction out of that, it will be less than 1 or will be equal to 1. It will be equal to 1. You sliced off 1, 2, 3, 4 part of apples. Of course, now you have the whole apple in your hand. That's what will make it 4 by 4. That is 1. So that is what proper fraction is. Proper fraction, like here 1 by 4, 2 by 4, 3 by 4, 4 by 4 will always be either less than 1 or it will be equal to 1, right? It will always be less than or equal to 1, and that is why you have numerator as the numerator of proper fraction will always be smaller than or equal to denominator. In this case it is smaller than denominator. In this case it is smaller than denominator. In this case this is 3, that is less than 4. In this case it is 4 equal to 4. So if you will calculate proper fraction, the value of proper fraction of this 3 parts, you will of course it's going to be less than 1, but if you will solve this one, you'll get equal to 1, and that is what we have discussed here, and we discussed why it's happening, right? In a similar fashion, if I take this pizza and here we have 4 pizza, 5 pizza, or so just, or let's make it 4 only, otherwise our discussion will get longer. So we have 4 pizza. Now if you remember, we said that your whole can be a single object like this one, or it can be a collection of objects. So in this case we assume that we have 4 pizza, the same pizza, and now we are assuming it to be a whole, a single unit. It is a single unit. Though it is 4 pizza, but if I take the collection of this 4 pizza, if I assume that this collection of my 4 pizza is actually a single whole, if you consider it as a whole, because if you go by the definition what we discussed here, if you remember, the whole may be a single object like this single pizza, or a group of objects like this 4 pizza. We are considering it as a whole. So this is whole. Now if this person A again comes into action, okay, and this person says that, hey, give me this one, I want this one, give me, sorry, if that person takes this one. So it will be here. This person A is having, this person A is having this pizza, this portion of the whole. So similar, it will be similar to this one. Now this person A is having this one. Okay, he took it off, he or she took it off from this whole. It's similar to this part. In this, a single object was sliced into 4 parts, and this, a single object that is our whole, is made up of 4 equal parts, right? So he took one part. So of course, in this case, this person A will be said to have 1/4 fraction, right? This is a proper fraction. Why 1/4? Because he or she took one single part. Like in this case, it was one part. In the same way, here the person A took this one part of this whole. So this person will be having a 1/4 of this whole. This is a concept of fraction. Now this person says, hey, I want this one also. Give me this one. So he takes out this one, the second part of this fraction, of this whole, sorry. So now this person will be having again this one. So now what happens? This person will be said to have, will be having the 2 parts out of 4. 1 pizza, 2 pizza, 3 pizza, and 4 pizza. Now he's having 2 pizzas, right? And so this time this person is said to be having 2/4. Remember again, in this example we took a single object. A pizza was considered as an object. Therefore, we were calculating our fraction on the basis of a single object. But in this case, we are taking our 4 objects as a collection, okay? And that is a whole. Now, this person says, hey, I want this one also. So you take out this one. Take out this one also. So it's here. Now this person will say, hey, now I have 3 parts out of 4. I have third part also. I have 3 parts out of 4. Then the person turns out to be greedy and said that, hey, I want this one also. So you take out this one also, and then it's here. Now this person will say that, hey, you know what? I have all the 4 parts. Therefore, I have all the 4 parts out of 4. 1 part, 2 part, 3 part, 4 part. 1/4 only when he got 1 part. 2/4 when he got 1 part and 2 part. 3/4 when he got 1 part, 2 part, 3 part. And 4/4 when 1, 2, 3 and 4. Again, this is a proper fraction. Why? Because it took out from a single whole, a single unit, where it was a whole was a collection of objects. This was first, this was second, this was third, and this was fourth. These 4 objects were making the single whole. In this case, this single whole was by a single object, right? So this is a proper fraction. Again, you can see that your numerator is always less than denominator, and in this case, it is equal to denominator. Therefore, again, this condition will be satisfied. If you solve these three, then it will be less than 1. And if you solve this one, it will be equal to 1. That's a proper fraction. Okay, now this was about proper fraction. Now, what if we just place these pizzas back to their position? Let's Control X. Pizzas are back in action, back to their place, and just remove all this. Sorry. Just remove all this. Okay. Now, what I say that I told you about proper fraction, but let's assume that if I remove this boundary of whole, remove this. I considered the collection of these 4 pizzas as a single whole, but just remove it. And now, this is a separate whole, that is a single unit. This is a separate whole, a single unit. Remember, now I'm telling you about improper fraction. This is a separate whole and this is a separate whole, a single unit. Okay. Now there are three boys, or say first boy, second boy, and third boy. You have to distribute these four objects, right? Four different objects. They're not a collection now. They are separate whole. This is a separate whole, this is separate whole, this is separate whole, this is separate whole. Now imagine that these are four pizzas and you have three boys, okay? Now, what you do is, you'll give this first pizza to this guy. So this boy will have one pizza. This person, second boy, will get this pizza. This will also have one pizza. This third boy will also get a one pizza. And it's three. We need what? We need, let me this is one pizza more. And in this case, let's take three. We need one more boy and one more pizza. Otherwise, okay. So let's take for example, let's take, one second. I need one more pizza to explain you this. Control C, Control V, this here. Okay. We have 5 pizzas to explain the concept of improper fraction. So this is a separate whole, and we have 5 pizza, and we have actually 4 boys. So there will be another fourth boy, a fourth boy. This fourth boy will get, so let me take some different color. Right. So this boy will also take this pizza. He will also have one pizza. Now there's a fifth pizza. Okay. Now the question comes that what to do now? We have distributed these 4 pizzas among 4 boys, but now we have a fifth one. So the first boy will say that, hey, it's simple. We have 4. Let's divide it into 4 equal parts, like we did here, right? So now you divide this. Now you divide this pizza into 4 equal parts. This will be first part. Sorry. This will be first part. This will be second part. Right? So this 1 by 4, this 1 by 4. Why 1 by 4? Because similar. We sliced a single object into 4 equal parts. A single object into 4 equal parts. So this part will be 1 by 4. This part will go to this guy, and therefore this will have 1 plus 1 by 4 pizza. Similarly, this person will get this portion 1 by 4, and this will go to this guy, and therefore this boy will have 1 plus 1 by 4 pizza. Okay. This third boy will get this portion, and this boy will have 1 plus 1 by 4 pizza. This boy will get this 1 by 4, and he will have 1 plus 1 by 4 pizza. Now deal is done. 4 pizzas distributed, single pizza to 4 boys, and then the pizza left was sliced into 4 equal parts and then distributed to them. Therefore they will have this amount, this amount, this amount, and this amount. Now you can write, just learn it, you can write this, this particular 1 plus 1 by 4, or say if you have something like this, a plus b by c. A, B, C are some arbitrary numbers. Okay, so you can write them as a B by C. Okay, so you can write it as 1 by 4, 1 by 4. This will also be 1 and 1 by 4. This will be also 1 and 1 by 4. Okay, such numbers are called mixed numbers. This representation is called mixed mixed number. Mixed number or mixed fraction, number of fraction. Okay, mixed number and mixed fraction. We will do a separate video on this to to solve several problems of mixed fraction, but just learn it here that this is a mixed number or mixed fraction, and to solve them what you will do is, if this is a mixed fraction, you will solve it in this way: a times c plus b divided by c. So this will be 4 times 1 plus 1 divided by 4, and therefore you will get 5 by 4. So in every case, in this case you will get 5 by 4, in this case you will get 5 by 4, in this case you will get 5 by 4, and even in this case you will get 5 by 4. That is, this person will be having, each boy will be having 5 by 4 pizza. Now what does 5 by 4 pizza actually means? It means that this tells you that one whole pizza plus 1/4 of that pizza, one whole pizza plus 1/4 of pizza, one whole pizza plus 1/4, one whole plus 1/4, one whole plus 1/4 pizza. Now since we are taking each object as a separate whole, as a separate entity, as a separate unit, then of course you're not, when you are calculating this fraction, of course it's telling you that hey, it's always going to be greater than 1, because you're adding something to 1. When you are adding something to 1, then that fraction will always be greater than 1. This is also a fraction and it is greater than 1. Of course, that's why you got 5 by 4. And since your numerator is greater than denominator, and that's what it tells, that when you solve this portion, that is 5 by 4, it will always be greater than 1. And what it tells, it actually tells that hey, you have one whole object plus something extra. And since you're not taking out fraction from a single whole, like we saw in the case of proper fraction, where we were taking off the fraction from slicing off from a single object, and we consider a single object as a whole or the collection of objects as a whole, and then we were taking a fraction out of it. But in this case, that boundary was removed. In this case, every object is a separate entity or a whole, and therefore it was distributed. Then of course the fraction is going to be greater than 1, because you are considering each object separately, right? So that is what an improper fraction is, and that's why the name improper fraction is. If you remember, we said that a proper fraction is in a true sense a fraction, because a fraction means that you are taking out a part of a whole, where whole can be a single object or collection of objects. But in this case, that boundary of whole has been removed, and here each object is behaving as a separate entity and whole, and that is why your fraction is going to be greater than 1. That's why the name improper fraction. But hey, that's a fraction. That is a fraction. Okay, because in mathematics, if you can write any number as a by b, then that will be considered as a fraction. Okay, so it's a mathematical term. When you will move to higher classes and you will learn more, so at this level we can discuss this much only. So improper fraction, if you solve them, it will always be greater than 1, and the numerator will always be greater than denominator, right? And why it's greater than 1? Because here you are distributing as separate objects, and then a portion of something left, slicing off it. Therefore it will be, of course, 1 plus 1 by 4 and it will be, the value will be greater than 1, and that's why the name improper fraction.